Okay, so simple linear regression. Okay, simple linear regression. Alright, so excuse me. Is there a linear relationship between rating and revenue for comedy and drama movies only? I'm gonna have you do something similar to this. It won't be drama and comedy, but it'll probably be another two different type of genres that you're gonna have to change up here. But this little line right here is getting rid of other. So it's only drama or comedy or drama and comedy movies. Okay. All right. So what we're gonna do is put my y variable. I'm gonna need to find my mean, which is going to be ratings. What causes which, logically speaking? Ratings causes money. Yeah, I'll say ratings causes money. Okay, ratings. Okay. Ratings. And this is going to be revenue. Okay, great. Copy ratings for standard deviation and also for correlation. Revenue for, you said do copy paste too, even though I know how to do this. For standard deviation, as well as for, and sorry, this X variable here, this is kind of confusing. What you're going to have to do is take this comedy genre, comedy drama, plug this here, okay, and then run enter. Alright, so this gives us the mean of our response, mean of our explanatory, standard deviation of our standard deviation of our y, standard deviation of our x, and the correlation between those two variables. That's quite low. But with these numbers, we can find the actual regression coefficients, B0 and B1. Okay? Alright. As you can see here, it still says x variable. I'm going to remove this, okay, and place it here. For my x and y variable, we're going to put rating. Again, we said the rating is our response. I don't know if that makes sense. I thought rating causes good ratings. Well, let's keep going with it. It's fine. This is crazy. I don't know how that happened. So let the ratings be that, and then revenue. Okay. So now if I run this, I'm going to get a visualization. So I got the summarization of my data, then my visualization of my data. Okay. Yikes. This is a linear relationship, but you know there's something else going on in terms of the clustering towards the left of the screen. Okay. There's a slight linear relationship that 0.114, was it? 114? 144. Not that big of a difference. But I mean, it is what it is. Again, this is in terms of millions, by the way. In terms of millions of dollars. Interesting. Alright, so then from there, what we'll do is I don't know why it keeps doing this. Don't pay attention to this. This should be the response variable. This should be ratings. And then this is going to be, revenue, based on how we set it up. And this is not quite correct. Okay, so what we're going to do is, did I save it? No, I did not. Well, this is going to be fun. We're just going to call this filtered. Hopefully this is not too advanced. That's a caret. I'll type it out. Caret minus. Boom. Okay. And then what I'll do here is just press. Oh, so therefore my plot's wrong too. My plot's not correct. My plot is not correct. Right? No, it is. Never mind. It is correct. Never mind. It is correct. So when I run this, it should still give me the same numbers. Okay, 0.144. Okay, fine. Fantastic. But then here, when I run this, I need to save it. I need to use the filtered one. And then when I run this now will give me my regression. It's not ratings, it's ratings. I don't know why it's taking so long to run. I'm so impatient. Okay, so here I'm giving my y-intercept, my slope. These are hypothesis tests for both of the regression coefficients if they're equal to 0. I don't know if you've gotten that far in class when you're watching this, but that's that. Huge. R squared is 0.02. This model is trash. I'm sorry. I said it. This model is trash. This model is trash. Even if I were to flip it, that should, 0.144 squared is really low. 0.20. So that's that. There's some regression assumptions. I hope that we've gotten this far in class. We only have Tuesday and Wednesday this week. We probably didn't get this far, but this just allows us to view the assumptions for simple linear regression. So every single statistical technique, there is assumptions. Okay, this is residual versus leverage. We're going to brush upon this, brush on that. Scale location, we're not going to talk too much about that, but here, the QQ line of our residuals, okay, we want most of our data points to be close to lines to say that the residuals follow a normal distribution. And then finally, our residual versus fitted. Now, this is a huge plot. This is important. Ideally, there should be no pattern. I would say there's no pattern. For the most part, there's no pattern, no general glaring pattern. Okay. That's it for this video. I'll make sure that your empty version of this makes a little bit more sense. You may have to do some finagling based on the questions, okay? Based on the questions with this aspect. Okay, so don't get too bogged down. Don't get too bogged down. Alright, thank you very much for watching and have a great day.